Let's say you have Salesforce org which manages devices data. Also, you have Java Spring Boot application and you want devices data from Salesforce to be securely synchronized to Java application. To achieve this, we will use OAuth 2.0 authorization framework with client credentials flow, which is ideal for server-to-server communication without user involved. So, let's get started. In this tutorial, I'm going to use Java application and Salesforce org from previous tutorial about integration from Java Spring Boot to Salesforce org. In that tutorial, we have implemented synchronization of device records from Java Spring Boot application to Salesforce org. In this tutorial, we will do vice versa, from Salesforce to Java. Link to the previous tutorial and code I'll provide below the video. In order to log in to Java application via OAuth, we need to set up authorization server. First of all, we need to add dependency Spring Boot starter OAuth authorization server. In security config, we need to add security filter chain bin for setting up authorization server configurations. Apply default security method configures the default endpoints required for an OAuth 2 authorization server like token endpoint, introspection endpoint, etc. Also, it adds filters necessary for handling OAuth 2 related requests. Let's register Salesforce OAuth client via which we will be communicating from Salesforce to Java application. We are creating an instance of registered client, providing it client ID and client secret, setting client authentication method as client secret basic, which means that during token request we need to pass base 64 value of client ID and client secret in authorization header, specifying that the client will be working only via client credentials flow, providing device admin scope, indicating that the token will be OAuth token and will require validation against authorization server. The values of client ID and client secret we will be retrieving from environment variables. To set up Java OAuth resource server, firstly we need to add Spring Boot starter OAuth 2 resource server dependency. Then we can define resource server security filter chain. Our resource server will be processing requests only to API path. Also, to access device paths, client need to have device admin scope. For all other paths, access is denied as of now. Then we are enabling OAuth resource server support and specifying that OAuth tokens will be used for token validation. Also, we need to specify introspection URL and client credentials so that resource server could validate the token. Disabling sessions to make every incoming request self-contained and independently authenticated. Also, we need to disable CSRF protection since resource server authentication is not session-based. Also, I would like to disable access to API paths for regular users since API paths are designed only for API calls. For better security, I'll add password encoder and use it to encode user password and client secret. For better convenience, let's make changes to retrieve user credentials from environment variables. Let's go to device service class and define here method to save devices data sent from Salesforce. As a parameter, we have an array of device data in JSON format. We are deserializing it and transforming to devices objects. At the end, we are committing changes to the database and returning the saved objects. To handle requests from Salesforce, let's create REST API controller. This controller will be processing requests made to API paths. Method saveDevices is responsible for taking in device data sent from Salesforce and passing this data to device service. Also, we are returning saveDevices data as a response back to Salesforce to be able to populate external IDs. We need to do one more important thing. Go to device.sf integration service class. In method createRequestBody, add population of lastly modified by device manager Java app indicator field. It will be used to avoid redundant update from Salesforce to Java after Java has made request to Salesforce. Let's create jar file for our Java Spring Boot application. Go to Maven menu and run package command. It will package the compiled code of our project into distributable format, that is jar file. In target folder we can see that our jar file is ready. Now we can upload our jar file to remote server. I'll use alwaysdata.com hosting. It provides 100 megabytes free plan with database. Let's create MySQL database, populate the name and press submit. Go to SSH remote access section. Just for this tutorial I will enable password-based login so that we could quickly connect to the server. For better security, remember to use SSH keys instead of password-based login. Copy SSH host. In SSH client, create new connection, enter a name, select SSH file transfer protocol, provide SSH host, go back to hosting administration, copy username, populate username in SSH client, press OK button. Let's connect to our remote server. Password you can set up in SSH user settings. Now we can copy Java application file to the remote server. Jar file is uploaded. Go to Sites section in Always Data, press Setup, provide command to run our Java Spring Boot application, populate all the needed environment variables, provide database host, database name, and database user credentials. Looks good. Press Submit, restart the application. Let's check if our Java application is working. Yep, it's working fine. There is no data since we have a brand new database. To be able to make callouts from Salesforce, we need to create external credentials and named credentials. In Setup, search for named credentials, switch to External Credentials tab, press New button, populate label and name, select Authentication Protocol as OAuth 2.0. As authentication flow type, select Client Credentials with Client Secret Flow. In Identity Provider URL field, you should provide token URL. Add device admin scope. Create new principal. Provide a name, client ID and client secret we should take from settings of our Java application. They are stored in environment variables. Copy-paste these values and press Save. Go back to named credentials. Create new named credential. Populate label and name. Provide base URL to Java resource server. Select Device Manager external credential. Press Save. In order to provide users with ability to make callouts, we need to give them access to external credential principal. For this purpose, let's create a permission set called Device Manager Sync. Go to External Credential Principal Access, select Device Manager Admin Principal and press Save. Assign this permission set to needed users. Let's create device DTO class that will contain data to be used in callouts. It has constructor with device record in parameter, so that we could conveniently set up device data. Also, we need to create device sync service class that will contain all the needed service logic. Method convert devices to DTOs transforms list of device records to list of device DTOs. Method update external DM app ID processes response sent back from Java and updates external ID field on device records. Since in trigger transaction we cannot make callouts, we will utilize queuable for this purpose. So let's create queuable class called device sync queuable. I prefer queuable over future method since queuable is more flexible. It allows passing complex objects like subjects or collections to queuable job, chaining queuable jobs, and also it supports finalizer, which is crucial for debugging failed queuable jobs. To be able to perform callouts, we need to implement database allow callouts interface. The constructor takes in set of IDs of device records that should be sent to Java application. Then we are querying required data, preparing request body, creating an instance of HTTP request with specifying named credential and external URL to be called, executing requests, retrieving body, calling device sync service to update external ID field. Now we can create device trigger to call queuable job. The trigger will be executed on after insert and on after update events. Go back to device sync service class and create here method that will take in list of devices from trigger, retrieve device IDs and pass these IDs to queuable job and enqueue it. Call sync devices to external DM app method from trigger. Let's imagine that in the future on Salesforce side, new fields will be added to device object, which should not be synchronized to Java application. If values of only these fields will get updated, we don't need to make callouts to Java application since it has no sense. The synchronization data is not changed. For this reason, we need to create a filter method. So go back to service class, create method filter devices to sync. It will take a list of new device records and map of old device records. If old map is null or empty, that means that this is insert operation. In such a case, we should return all the device records. Otherwise, we are verifying if any of the fields that should be synchronized is changed, and if so, add it to the device to sync collection. Let's utilize this filter in device trigger. One more problem we need to solve is, since we have two-way integration, when Java sends updates to Salesforce, device trigger will be executed and logic to make callout to Java app also will be executed. This is a redundant callout. To avoid it, we need to utilize indicator field called lastly modified by DM Java app, which is always set to true value when callout is made from Java side. So let's define static indicator variable called isItDM Java app integration context and set it to false value by default. In method check if it is DM Java app integration context, we are verifying if update is done from Java side and respectively populating our static indicator. If it is Java side update, we need to reset the value of lastly modified by DM Java app field. Now we can go back to device trigger and call this method in before insert or before update context. Also, before making callout to Java, we need to make sure that this is not a Java update context. Let's deploy the code to Salesforce org. The code is successfully deployed. Let's check how our integration works. On the left-hand side, I have Salesforce org. On the right-hand side, Java Spring Boot application. On the Java side, there is no device data since we have a brand new database. Let's update device record on Salesforce side and see if it will be reflected on Java side. Let's go to Apex Jobs page. We can see that our queuable job was successfully run. Let's go to Java side. Refresh the page. Cool! The device was successfully sent from Salesforce and created on Java side. Now let's update two device records simultaneously. Both device records are created on Java side. If we refresh list view on Salesforce, we can see that external ID field is populated with value from Java system. Now let's create new device record on Salesforce. Amazing! On insert of device record, it also works well. Let's try to update device record on Java side and see if changes will be reflected on Salesforce side. The device record is updated on Salesforce side. Perfect! So, in these two video tutorials, we have successfully implemented two sides integration between Salesforce and Java Spring Boot application. Thanks for watching!